Hello everyone, welcome to my YouTube channel. Today I'm solving Leetcode question 1254, number of closed islands. This problem is a more complicated variation of the classic Leetcode question, Leetcode 200, number of islands. This question is also very similar to the Leetcode question 1020, number of enclaves. I have already uploaded my solution and video for these two questions. So if you haven't checked them yet, please feel free to take a look at my videos. So first, let's try to understand the problem statement for the number of closed islands. Given a 2D grid consists of zeros, 0 here means land, and 1 here means water. An island is a maximum 4-directionally connected group of zeros, and a closed island is an island totally all left, top, right, bottom, surrounded by water. So return the number of closed islands. So the problem statement is a little bit complicated. So let's try to understand the problem a little bit better by taking a look at the example. So for the example 1, given this grid, there are 2 closed islands in this grid. So the first one is this standalone 0. Remember, here 0 means land and 1 means water. Because this standalone 0 is completely surrounded by water, surrounded by 1 in all 4 directions, left, top, right, bottom. So this one is a closed island. The second closed island is this one. So this one is a little bit complicated because it's not just consists by all the zeros. It also has ones in between. So there's actually a lake in the middle of this island. So remember, in the problem statement, it says an island is a maximum 4-directionally connected group of zeros. Pay attention to the word maximum. So in this case, for this island cell, it has value 0, which means it's a land. And then it's surrounded by ones, let's say up and then bottom. So it only surrounded by 0 in 2 directions. So it's connected to zeros to the left and to the right. But it still satisfies our definition because an island is a maximum 4-directionally connected group of zeros. So for this closed island itself, in order to satisfy the requirement to be a closed island, it has to be totally surrounded by ones, which means if we going through the boundaries of this island, you will see that this entire island is surrounded by ones, surrounded by water in all 4 directions. So that's kind of the problem. So that's why, given this grid, we have 2 closed islands. So let's take a look at the second example. This one is just very simple. So basically for this one, we have a standalone island in the middle, and it's surrounded by water, surrounded by 1 in all 4 directions. So now we have understand the problem statement, how to solve it. So the basic idea is to solve it using depth first search. So we can keep track of the DFS traversal. Let's say if once we hit the boundary, which means once we hit the boundary and then the boundary is actually not water, then we know that it's not a valid closed island. So basically we just utilize the depth first search and then return a Boolean value. The Boolean value is true if this island is a closed island. And then the Boolean value would be false if this island is not a closed island. And then we just keep increase the number of island if the island is actually a valid closed island. Otherwise, we are not updating our counter. So that's the basic idea for solving this one. So let's try to code this up. First, get the dimensions for this grid. And then code up the main framework. That's kind of a habit of me to code up the main framework before dive into the DFS function. So let's say for this one, we loop through every cell on the grid. And then if that cell represents a land, remember here 0 represents a land. So if that cell represents a land, we start our DFS traversal from that cell. And then during the traversal, we are trying to visit all the cells connecting to this land cell. We are trying to visit all the island cells connecting to this one. And then after that, we will finish traversing the entire island and then we return. So if this island is a closed island, we return true, otherwise we return false. So in that case, if true, then we increase our counter. So we have to initialize a count variable. If it's true, we just update the count. And then in the end, we just return the count. So now let's code up the DFS function. So DFS ij. So basically for this function, let's define this function. Okay, so return true if so let's first try to check. So basically if we hit a boundary, which means if we hit a water boundary, so the grid value is 0. In that case, we just return true. And then later, we will also utilize grid value assigned to 0 to indicate this grid cell has already been visited. So this one means if we hit water boundary or already visited, then we return true. Else, if we hit a grid boundary, in that case, we just return false. So this means, let's say, okay, if we encounter the 0, but then the index of that 0 is located adjacent to the boundary of this grid. In that case, it means it's not surrounded by water, or it is already outside the boundary. So in that case, this island wouldn't be a valid island, wouldn't be an enclosed island, because it's not completely surrounded by the water, which means completely surrounded by all the ones in all 4 directions. Remember, in this problem, the boundary of the grid is not water. So for some problem, they assume, let's say, for all the area outside the boundary of this grid, we assume they are water. But this is not the case for this problem. That's why if we take a look back at example 1, so we have some zeros here. So these zeros has ones to the left and then have ones below it, so surrounded by water in these 2 directions. But these zeros are also connected to the boundary of this grid. And then in this problem, we are not assuming the boundary of the grid is actually water. So in this case, this cluster of zeros is not a valid closed island. So here, we just utilize this condition to check that. Okay, after check the condition, so we'll start with this grid cell ij. So we first mark it as visited. I assign 1. And then how can we determine if this entire island belongs to a closed island. If this island is actually a valid closed island, we're just trying to move in all four directions. And then if for in all four directions, let's say if we check and find, okay, in all the four directions connected to this cell, there are actually valid island cell. And then for those cells, they are not actually outside the boundary or reach the boundary. In that case, we know, okay, this DFS will return true. So in that case, we first start a variable called result, and then we initialize it to true initially. And then we start traversing in all four directions. For the new x, y, which means for the new row and column index, the I plus 1j means moving down. I minus 1j means moving up. J minus 1 means moving left. J plus 1 means moving to the right. So in that case, we just update our results. So let's say, okay, we are moving in all four directions, and then through the traverse, we update our results and then return it. So now we finish coding. Let's check our solutions. Okay, so this is the solution to this Leetcode question, solving utilizing depth-first search algorithm. If you like my video, please feel free to subscribe to my YouTube channel. Thank you.